Hello everyone, and welcome back to statistics. Woo! Alrighty, so because we're not in class, I'm going to condense these notes a little bit, so I don't want you to worry about the first two vocab things. Instead, the main vocabulary that we need to pay attention to is probability, which is the measure of the chance or likelihood an event will occur. And in order to find probability, it's going to be the number of desirable outcomes divided by the total number of possible. So it's going to be want over total. Okie doke. Alrighty, so let's take a look at our very first two-way table. So this is a two-way table. It is called a two-way table because you are comparing two different subjects. Like right here we have school clubs, and then we have gender, male and female. Alright, so let's just take a look real quick at how to read a two-way table. This is saying that there are 12 males in band, and there are 21 females in band, and there are 33 total people in band. And then there are a total of 135 students. Alrighty? So, how many students participate in a school club? Well, these are all of our school clubs, and we have a total of 135 students. Alrighty, and which category are we least likely to find a female? Well, check out your females and see which one has the least number in it. That's going to be our chess club, because there were 3 females in chess club. Alright, and which club is most popular? So this isn't asking about male or female, it's asking about the total number of people. So we're going to go to our totals, because over here are over here is our total amount of club members. And so see which one has the biggest number in it. And that's going to be the 35, which is yearbook. And then finally, what's the probability that a student is in Latin club? Alright, so this is the want over the total. So we want the kid to be in Latin club. So that's going to be 16. And it's going to be over our total, which is 135. And so that's going to give us 0.12. And yeah, you do kind of want them in decimals. Alrighty. So, let me see about this really quick. Yeah. Number 2. A public opinion survey explores the relationship between age and support for increasing the minimum wage. So how many people were surveyed? Well, that is our total, which is going to be 200. And how many people are over 60 years old and against increasing minimum wage? So over 60 and against, that's going to be 20 people. Alright, and next, let's see if I can do this. Here we go. Alrighty, so how many people between 41 and 60 years old have no opinion? So 41 and 60, no opinion, that's going to be 15 people. And what is the likelihood or probability that a person is for increasing minimum wage and is in between 21 and 40 years old? So that's going to be the want over the total. So for increasing minimum wage is right here, and between 21 and 40 is 25 over our total, which is 200. And so 25 divided by 200 is going to give us 0.125. And then what is the likelihood or probability that a person is over 60 and against minimum wage? So over 60 and against is going to be 20 over our total of 200, which is going to give us 0.10. Alright, cool. So now, onward. Let's see. Yeah. So how many women prefer going to the movies? So women, movies, 8. And what is the likelihood, there's that key word, probability, that a randomly selected person is a woman and prefers movies? Well, we said that was 8, And so then we have to put it over a total of 50, which is going to give us 0.16. Yes, that is supposed to be a 50. And what's the total number of students who prefer sports? Well, that's going to be 16. And what percent of college students surveyed prefer dance? So percent is also asking about probability. So people who prefer dance is 18 over 50, which gives us 0.36. And because it asked us for a percent, we have to change it to a percent. It's going to be 36%. And then what percent or probability of those surveyed preferred sports as their hobby? So that's going to be 16 over 50, which is going to give us 0.32, which is going to be 32%. Very good. All right. Relative frequency is basically probability. All of these decimals that we've been solving for, these are relative frequencies. These are probabilities. And so it's the ratio, or the fraction, of the number of times an event occurs, the want, to the total number of outcomes, or the probability an event will occur. It should be expressed as a decimal, like we've been doing, unless it asks for a percent. And the total relative frequency should be 1. And don't worry about conditional frequencies. Alrighty. So now it wants us to create a relative frequency table of the hobby table above. And so we'll get it started just to show you guys how you solve for it. Actually, can I get both of these? I can on the same page. That's so nice. I haven't been able to do that. Okay, so for our relative frequency, women in dance, well, that was 16 over our total, which is 50. And then you want to change that into a decimal to get 0.32. And then men who prefer dance is 2 over 50, and that's going to give us 0.04. And then the total is going to be 18 over 50, which is going to give us 0.36, which actually makes sense because if you add these two decimals together, you'll get 0.36. All right, and then I'm going to go this way. Okay, so women who prefer sports is 6 over 50, which will give us 0.12. Women who prefer movies, 8 over 50, 0.16. And then women, total women is 30 over 50, gives us 0.60. All right, and then I'm going to do the total, which is going to give us 50 over 50, which gives us 1. And that's what this statement meant. The total relative frequency should be 1. So your total should be 1. All right, I'm going to let you guys finish filling this out, okay, because we got to move on. Alrighty, so this is our total relative frequency table, and it is mostly filled out. We just have to finish it up a little bit, okay? So add up these to get our total, and that's going to give us 0.80. Add up these to give us our total, to give us 0.20. Add up these to give us our total. Add up these. And then you can either add this way or this way, but it'll both give you 1, which is what it should be. So what must your total relative frequency equal? Well, it needs to equal 1, because this is our total relative frequency. All right, what's the probability that a member surveyed plays bridge? So plays bridge, total is 0.80. That's the great thing about this type of table. No calculations required. You just look, oh, that's the probability, okay? And it will always tell you relative frequencies, okay? So then what's the probability that a member swims and does not play bridge? Swims, does not play bridge. Oh, that's 0.08. Alrighty. Now, how many members do not play bridge? So look at the probability that they don't play bridge, which is 0.20. And then we need to multiply it by the total number of members. Oh, wait a second, that's not in our table. Where are we going to get that from? Maybe we should read, the top piece. A recent survey of 250 people at the country club asked members if they do all this fun stuff. So our total is going to be the 250. So that's what we're going to multiply this by to get 50. Alrighty. And then, what's the probability that a member plays bridge and swims? Yay, back to probability. Plays bridge and swims is 0.72. And then how many members swim and play bridge? Alrighty, so swim and plays bridge, that was the 0.72 times 250 will give us 180. Alrighty. And then, missing a question. How many members swim and do not play bridge? So swim and do not play bridge. Let's see. Swims and does not play bridge. That was the 0.08 that we used earlier. And then we're going to multiply it by the total number of members to give us 20. Very good. Alrighty, we have one last thing to do. And then we'll be done with two-way frequency tables. We have to learn about conditional probability. And this one's a little bit harder, but I'm going to try to make it easy for you guys. Alrighty, so conditional probability of an event is the probability that event B occurs after event A has already occurred. So basically, what I want you to look at is this right here. Okay, number of A and B, and then the total for A. Okay, this is what we need to look at. This is the big boy. And given that is always on the bottom. Okay, so wherever it says given that, that's the total for A. Alright, so then let's take a look at some examples. So it's still going to be a two-way frequency table. It's just the type of question that they ask. So a recent survey asked 100 people if they liked ice cream more than pizza, and the results are shown. So we need to find the probability that a person says yes, given that the person is female. So given that always needs to be on the bottom of our fraction. So our total female needs to be on the bottom of our fraction. And then female and yes needs to be on the top. Okay, so female and yes is 8. And then our total female is 50. So that's going to be 8 over 50, which is going to give us 0.16. Alrighty, let's try the next one. Find the probability that a person answers no, given that the person is male. So we're going to have total male under, and then we're going to have male and, what was the other piece of it? No. So male no is 18 over our total number of males, which is 50. And that's going to give us 0.36. Okey-doke. Given that the person said yes, so now total yes over yes and. Look for the other piece of information. What's the probability that the person was female? Okay, so yes and female. So yes, female is 8 over our total number of yeses, which is 40. So 8 over 40 is 0.20. And then we have given that the person said no. So total no. What's the probability that the person was male? So total no is 60. And then no and male is 18, which is going to give us 0.3. There we go. All right, if you guys want extra practice, you guys try 6, okay? But this is it for now. Good job, guys.